Want to talk to you about Rails engines. I found them to be incredibly helpful for maintainability and for extracting specific modules that can live independently from the main application. During Rails World 2024, it was my first international conference, I got inspired by the amazing Ruby community and thought I should give back something. So I made Active Storage Dashboard available as an open source project. It's a small contribution, but it's still mine. I've been heavily using engines to make huge legacy applications more modular and maintainable for about 5 years now. And somewhere along the way, I got to love engines. I really love them, and I want to spread some of this love with you. Let me quickly introduce myself. I'm Giovanni Panasiti, and I'm a developer and entrepreneur based in Rome. I'm specialized in Ruby on Rails development for complex, high-stakes environments and legacy code bases. I work for a government agency in Italy, and that's where the expertise for the legacy applications come from, where I build and maintain systems serving over 600,000 unique users, with some application used to be spanning between Rails 3 and Rails 8. Now, luckily, we are on the lowest Rails 6.1. I also run my own agency, specializing in Rails consultancy, and I co-founded a SaaS specific to Italian HR to help companies to stay compliant with the law. So it's 2026, and we're still talking about Rails engines. Aren't we all supposed to be doing microservices now? Yeah. Let's talk about why management usually think they want microservices. First, it's a nice buzzword. It sounds modern. It looks great on architecture diagrams, and it looks great on slides. But underneath the buzzwords, there's actually a legitimate goal. They want teams to be independent. They want Team A to write code without breaking Team B works. They want clear boundaries. So, but microservices are not the only solution. Microservices are a technical tax. You pay for them in complexity. You need Docker, you need Kubernetes, or something else to orchestrate all those containers. Your method calls turned into API calls. And so suddenly debugging everything means tracing requests across different network boundaries, firewalls, correlating logs from different services. So a nightmare. I proved my boss that engines could give us the same independence without the overhead. Each team owns some engines. The boundaries are clear, separate code bases, independent test suites. Code reviews stay within the team. It's the same separation of concern you would have with microservices, the same organizational autonomy, but you only have one database to manage and one application to deploy. So you got the modular architecture within the modular monolith simplicity. And unlike microservices, there's no network overhead, no deployment complexity, no distributed system. It's just Ruby code that happens to live in a different gem. So yeah, I love engines. We all read the Rails guides on engines. Maybe not everyone, but there's still a gap between making it work and making it maintainable across different host applications. Today, I'm now going to talk about how to generate an engine, because it's just a line on a terminal. Instead, I want to share lessons that I learned while using engines. Sorry. These patterns allowed me in the past to make my engines feel like a native part of the host applications while remaining completely isolated and easy to install and maintain. We're going to move from basic integration, like sharing authentication, to the more complex challenges of supporting multiple databases and many Rails versions without creating a dependency nightmare. So here's the roadmap for today. It's 8.8 lessons that I've tried to order them roughly by how early you will hit them when building an engine. Let's start with isolate namespace. Probably the most misunderstood line you will find in an engine, because most of the time you don't even write it. When I created my first engine, I didn't even know what it was. It was there just because it comes by default when you create an engine with the mountable flag. Sorry. With isolated namespace, we're not just getting our code namespaced. We got 5 distinct isolation, and let's go to see one by one. The first one is table name prefixing. So this matters because your engines, if it lives in a gem and you're distributing this to apps that you don't control, you have no idea what tables they already may have. Maybe they have a document model, and you have a model that with the exact same name. Now your migration will break, or even worse, you're trying to write to the data. So the prefix guarantees your engine's data stay in their own line. Route namespacing, it encapsulates all the routes of your application within their own namespace. And the host application route will still be available to you via the main app helpers, so main app dot route name. Helper method scoping, without isolation, your helpers will get mixed in the global helper namespace. Every view in the host application can call your methods. If it sounds convenient, it's not. What if 2 helpers have the same name but do different things? With isolation, your helpers will be scoped to your engine's views. The host application can still include them if they want, but it's opt-in and not forced. Controller inheritance, your engine gets its own application controller. It inherits from action controller base and not from the host application controller. This is huge because it means your engine doesn't automatically inherit all the host authentication or the before action callbacks, their layouts, whatever. Is that good or bad? It really depends on what you're building, but it's very important that you know this is happening and you are aware of it while designing your features. Last one, isolate namespace also namespace your asset pipelines. So this prevents class collisions and gets your assets in a specific folder with your engine name. Configuration, so every engine needs some configuration. Base controller class, pagination sites, feature flags, authentication callbacks, storage backends, whatever. Ruby gives us a mat accessor, so the module accessor for module level settings, and it works great. First, I always like to provide sensible defaults when it's possible. So if someone forgets to configure your engine, it should still work. Application controller, for example, as you see in the code, is a safe default for the base controller. 20 items per page is maybe a reasonable sample for default for pagination. The goal, when possible, is to have a 0 configuration happiness. They can install the gem, mount the engine, and everything just works. Configuration should be for customization, not for making things run at all. And second, and this goes back very often, store class names as strings. And you can call constantize at runtime when you actually need a class. These avoid load order issues. I cannot stress this enough. I've seen so many engines break in test because they try to reference a user class or application controller class at boot time before Rails had finished loading. Strings are lazy, strings are safe. Store application controller as a string and then call constantize when you need it. Provide a nice configuration block API. It reads better than setting a bunch of module attributes individually. The block pattern is what developers expect. It's what device does, it's what Sidekick does, and what every well-designed gem does. It says out loud, this is the place where you want to configure this thing. And validate your configuration early if you need to in your engine's initializers. Check that required settings are present and raise helpful errors if they're not. Nothing is worse for someone who's installing your gem to have an error 20 seconds after bundle install. The authentication problem is is probably the most important one to get right. So here's the problem. Your engine has controllers, and those controllers need authentication. but you don't know how the host application will handle authentication. Maybe they use device, maybe they use Clarence, maybe they use a custom solution, maybe they have an admin controller with all their before action for role authorization. A very common pattern you will meet is to suggest users handle authentication via route constraints. And that works for a while. You tell them to wrap your mountain engine in a constraint, maybe check for an admin flag, and call it a day. But route constraints run very early in the request cycle. You don't have access to controllers helpers. And if the logic is more complex than a simple Boolean check, like they need role-based permission, organization, whatever, you're fighting against the convention, not working with it. So the solution is really simple. You can let them configure which controller to inherit from. You can make so that your application controllers inherit from whatever they configure in the engine configuration. And now they have full control on who can access your engine's routes. The beauty of this approach is that you've completely removed yourself from the authentication equation. You're not shipping device integration code that breaks when they're using roadout. You're not maintaining compatibility for 6 different authentication libraries, and you're not writing documentation for every possible auth setup. You're just saying, tell me what controller to inherit from, and the problem solves itself. Database compatibility, it beat me hard at first, because you never know what database the host application is using, but you still want to support as many adapters as possible. Sometimes you need to support adapters that are not even defaults, like Oracle in my case. I find a good solution is to detect the database adapter at runtime. You can ask Active Record what database it is connected to, and then branch your SQL accordingly. Now, most of the time, you can avoid this entirely by using standard Active Record queries. But sometimes you may need raw SQL, and when you do, this pattern saves you. Rails, lesson number 5 is about supporting multiple Rails versions. When I build an engine, I want it to support as many versions of Rails as possible. And I can find some pretty significant API changes between different versions of the framework. So how do you handle that without your code turning into a mess of version checks? The answer is feature detection and not version detection. Instead of checking, is this Rails 7 or Rails 6, you check, does this object respond to this method? If it does, great, you can use the new API. If it not, you can fall back to the old way. For constants and classes, it's the same thing. You can use the define method to, for example, in Rails 6.1, they added variant record in active storage, but Rails 5.2 doesn't have it. This pattern lets you handle both cases in an elegant way. This is also the way Avo, our sponsor, have built their engine so that it can support either PropShaft or Sprockets for the asset pipeline in the host application, for example. And this one might be controversial. I always tend to have zero dependency when possible. So Active Storage Dashboard has a full admin interface. It has tables, filters, pagination, and it still uses no dependencies and non-bundler. I avoid any third-party jam unless it's really strictly needed when I build my jam. Pulling in a lot of third-party jams can work against you. You lose control. Every dependency brings its own rules, its own updates, its own breaking changes. If a jam stops being maintained, your jam is affected and you now have a problem. And you're passing down your problem to your users because the users trusted you and inherit your dependencies. Security patches become a nightmare for them. If your engine locks some dependency to an old version of something, your user might not be able to upgrade to get critical security fixes. That's a serious problem. So before adding any dependency, ask yourself, can you build this with what Rails already gives? The answer is usually yes. Service classes, it's not an engine pattern, it's pattern you find everywhere. Engines often need rake task. In my case, I needed rake task for cleanup, orphaned blobs, or regenerate variants, and that kind of thing. The temptation is obviously to put it in the logic right in the task definition. Don't do that. Look at this service class. All the actual logic is here in a plain Ruby class. The rake task becomes just a theme wrapper that calls this service. This is obviously a good pattern for Rails, not for engines, not just for engines. But in engines, it matters most. It matters even more because you're shipping code that people will need to debug, extend, or maybe trust with their own production data. Why is it better? 3 reasons. First, you have testability. The code is testable. You can unit test this service directly, way easier than testing rake tasks. It's reusable. Now you can call it this from a controller for the console from a background job. The rake task is just one entry point. Third, this is optional, but it works. Make it to be safe by default. You see that the dry run parameters that defaults to true. That means if someone runs this in production and forgets the arguments, it just shows what would happen. It doesn't delete anything. So you have to be explicit and write, let's say dry run false to make changes apply. Filter classes. Let's say you have a controller that lists files. And user can filter by content type, file name, sites, whatever. The naive approach is a bunch of if statements in your controller, but that gets ugly fast. Instead, you can extract all the logic into a filter class, pass it to the initial scope and the params, call apply, and you get back the filter scope. The benefits is that your controller stays skinny, your filter logic is testable in isolation, and when you need to add a new filter, you just add one more than call and a filter method. I use this pattern everywhere now. It's one of those things that feels like an overkill at first, but then it comes natural and you miss it when it's not there. All right, zooming out. When I build an engine, I always keep this in mind, and you should too. You're designing for the host application, not just for your own. So your engine is a guest in someone else's house. You don't get to complain about how they've organized their kitchen. You adapt, you integrate, and you make yourself useful without making yourself in the way. So authentication, you don't invent your own. You tap into whatever they're already using. Dependencies, same thing. Every gem you add is potential conflict with their gem file. So that's why zero dependency, it's not just philosophy, it's respect for their dependency tree. The pattern is consistent. Your engine should adapt to them and not the reverse. And that's it. Active Storage Dashboard Gem is open source. If you want to see all this in practice, I've tried to keep the code pretty readable, so feel free to dig around. I love to hear your questions, so don't be afraid to block me on the hallway, or if you think about it later, you can reach me up on Twitter X. Thank you.